All right, college algebra. Looking at linear functions today. Linear functions. Okay. As we look at lines, you could have a line that goes like this, or a line that goes like that. In these lines, though, the most important thing we have is called the slope. What is the slope of the line? And we've already talked about that as far as the formula. This is the slope formula that we've already mentioned in this class. Okay, but what this means is this. The slope is the rise over the run. How much it goes up versus how much it goes over. See, your y's right here, when you subtract your y's in this slope formula, you're figuring how much it rises, how much it goes up. And when you subtract your x's down here, you're figuring how much it goes over. And so this is your slope, your rise over your run. We have four main kinds of slope. We have one that may go like this, which is positive. We have one that goes like that, which is negative. We have one that goes straight across like this. This is a zero slope. We have one that goes up and down. This is undefined. So these are our four main kinds of slopes. Now, slopes, this is a positive slope. All right, here's another positive slope. But you can see they're sloped differently. Now, if you look at this one here, this goes up 1 and over 1. So the rise is 1 and the run is 1, which is just a 1. That's a 1 slope. But this one here, it looks like it goes up 2 and over 1. It goes up 2. So my rise is 2 over 1, which is 2. So you can see the steeper it is, the bigger the slope number is. And of course, if you look at this negative one right here, see this one here, if I pick this point, I go down 1 and then over 1. So negative 1 over 1, which is negative 1. This is a zero slope because if I take 2 points on here to get from this one to that one, I don't go up any at all. So my rise is 0, but I go over maybe 2, which is just 0. And then of course undefined, if I have 2 points on it, well, from this one to that one I may go up 2, but I don't go over any. So the zero's on the bottom, and we've already talked about that in here. That would be undefined. We can't divide by 0. So this is your four main kinds of slopes: positive, negative, 0, and undefined. Okay. Well, let's look at what we got here. On this first one here, I've already looked at this and circled it. Identify the line that could have the slope of -5, which is this one here. But if you look at these four here, this is a negative slope, this is a 0 slope, this is a positive slope, and this one's straight up and down, which is undefined. So you should be able to just spot those, and the only one this possibly could be is A, because it's negative, and that's the only negative one. Well, number 2 here, identify the line that could have the slope of 0. All right, 0 is straight across, which right here it is clearly C. But see, this is positive, negative, 0, undefined. You should be able to spot those real easy. All right, number 3. Identify the slope of the line that identify the line that could have the slope of 2, which is positive. All right, well, this is the positive one right here. So it's got to be that one. Positive, undefined, negative, 0. And then down here, identify the one that could be the undefined, which is here, undefined. Negative, 0, positive, undefined. Okay? Now, to get to number 5, we're going to have to go to the video over here. So let me get to number 5. Okay. All right. So we have this. I don't know if that would make it any better. We'll just do it this way. Okay. We want to graph this following function and give the domain and range. So as I graph this, I'm just going to click on the graph, okay, and I'm going to tell it that this is a line, and then all I got to do is pick 2 points. Well, I'm going to take right here for x, I'm going to put 0 in for x. So if I put 0 in for x, what's 0 minus 2? Well, it's negative 2. So I'm going to come over here, and I'm going to stay on 0 for x, and I'm going to go down 2, which would put me right there. All right, then I'm going to pick another value for x. So what if I put in 3? So 3 minus 2 would be 1. So that means at 3, the function value is 1. So it'd be right there. So that should be my line. Okay. And we're good. Okay. Now we want to figure out what the domain is. Now notice on this right here, we've got the domain is this, the domain is this. All right. This one, if you notice, it's got braces. This is if you have individual values, like suppose you had a function and it only had x values of 3 and 6 and 7 and 12. Then you would just list those in this option with the braces. But on this one, we got a whole interval because it goes, this line right here, we got infinite many number of points here. So we're just going to do the interval, which goes in this box here. And the domain is left and right. So what's the furthest to the left that this goes? Well, it goes forever to the left. What's the furthest to the right that it goes? Well, it goes forever. So this will be negative infinity to positive infinity. So I'm going to do parentheses, negative, and here's my infinity down here, comma, and then positive infinity, and then put the other parentheses, and there we go. Fantastic. All right. What's the range? All right, the range is also going to be an interval, so it's in this option right here. So I'm going to click on that box. We don't want the braces because we need an interval. And what's the furthest down that this goes? Well, it's going to go to negative infinity. So this is going to be the same as the domain. So I'm going to have parentheses, negative infinity, comma, positive infinity, parentheses, and there you go. Fantastic. Okay. Now, is this a constant function? All right, a constant function means that your y value is always the same, which means it has 0 slope. This does not have 0 slope, so no, this is not a constant function. A constant function will have 0 slope. All right, so we've done that one. Let's go to 6. Okay, same thing here. Graph this function. All right, so we're going to click on the graph. We're going to tell it we're graphing a line. And if I put 0 in this, 2 times 0 would be 0. So if I put 0 in, I get 0. So 0, 0. Now let's put another value in, like 4. 2 times 4 would be 8. So if I put 4 in for x, right there's my 4, I'm going to have to go up to 8 for the y. There you go. You could pick any values you want. I could have just picked 1 if I wanted to, but I picked 4. But anyway, it should graph the same line, no matter what, as long as you do your math right. Now, is this a constant function? All right, again, a constant function is a 0 slope. This does not have 0 slope, so no, it's not a constant function. Okay, all right, nice work. Now, what's the domain? So the domain on this, I'm not going to do it. But you'll select down here because you got to do an interval. Look, notice how they switched them this time. They put the braces one on top. You got to be aware of that. But it's an interval, so it goes down in here, and it'd be negative infinity to positive infinity. So I'll save you the hassle of doing that. Let's go to 7. Okay. All right, get it loaded up here. All right. So in this one now, graph the following function. Give the domain and range. All right, we're going to click on it, and then we're doing a line. All right, now this one actually is constant because you see there's no x value in here at all. So that's a dead giveaway right there that this one is constant. Now, if I put 0 in for x, I'm down here at negative 8. And if I put 3 in for x, I'm down here at negative 8. Because no matter what I put in for x, I'm going to be negative 8. If I put 8 in for x, I'll be negative 8. No matter what I put in for x, I'm going to be negative 8, which gives me this straight flat line with 0 slope like we knew we were going to have. So yes, this is a constant function. Now we got to put our domain and range in. All right, my domain, the furthest to the left it goes, negative infinity. The furthest to the right it goes is positive infinity. All right, so negative infinity to positive infinity. Oops. I didn't mean to do that. I lost my infinity. There it is. Okay, so there's my domain. Now, what's my range? Now, look at this one now. What's the furthest down it goes? What's the furthest up it goes? Well, on this one, it's just 8, negative 8. So on this one, my range, I'm going to select this option because that just has that one value, negative 8. That's the only range value we have. So we'll put it in here in the braces. Okay, so there's the difference here on why you select this box versus why you would select that box. My range only has that one value, so I put it in the braces. Now, is this a constant function? Yes, this one is, because it has 0 slope. It just has that one value for y. Okay, there we go. Let's go to number 8 here. Okay, now graph this line. Okay, now this one here is a little bit different as far as like it's got 4x minus negative 4x plus 5y equals 20. This is actually what's called a standard form of linear equation. So I'm going to click the box. When you have standard form, click we're telling the line. The easiest thing to do is you put 0 in for x. And if I put 0 in for x, negative 4 times 0 would be 0. That would go away. And so then I would have 5y right here equals 20. Okay, so that would go away. So 5y equals 20. I would divide by 5. That means y would be 4. Okay. Maybe I should just move my camera back. We'll do this on paper so you can see what I'm talking about. Okay. Let me get a piece of paper here. I'll write it out here. So negative 4x plus 5y equals 20. All right, if I put 0 for x right there, 0 for x, this is going to go away. So that means 5y equals 20. So 5y would equal 20, which means I would divide by 5. Y would have to be 4. So 0, 4 is one ordered pair. Okay, now if I put y, I put 0 in for y. Okay, that means this would go away, and so that means I would have negative 4x equals 20. So I divide by negative 4. That means x would have to be negative 5. So that means I would have negative 5 as my x, and then 0 would be my y. And that gives me these 2 points right here. And that's the 2 points I would use to graph this on the graph. So let me go back to the... All right, so that means I'm going to click on this, which I already did. So I'm going to just put those 2 points. The first one was 0, negative 4. I'm sorry, 0, positive 4, which is right here. Then I had negative 5, 0, which is right there. Now, if you notice down here at the bottom, it tells you where you're at. So if you can't really determine where you're at, see, it moves around and it tells you exactly where your points are. Negative 5, 0. And I notice if you click on the wrong one, oh, I did it wrong. You can just grab it and then nudge it over. And there you go, you're on the right one. So there's your line. And let's check it there. Okay, we're good. Then you're going to do your domain and range, which anytime you have a line, unless it's a 0 slope or an undefined slope, it's going to have a domain, negative infinity, positive infinity, and I have a range, negative infinity, positive infinity. So we'll not do that on typing it in. Okay, and we're going to go back to our paper here. I do want to tell you this right here. If you have a line that looks like this right here, okay, this type of line right here is what's called slope intercept form. This is called slope intercept form. right here's my slope, and right here's my y-intercept. So it's called slope-intercept because here's your slope and here's your y-intercept right there. So slope-intercept form. Now the line we just had is what's called standard form. Which it was this right here, negative 4x plus 5y equals 20. So notice the difference here. This slope-intercept form, you got y all by itself, y equals all this over here. Standard form, you got your x's and y's over here, and you got numbers times them. So you got like these coefficients. So negative 4 times x plus 5 times y, and it equals a plain number over here. That's called standard form, which is the one we just did. Okay, now let's look at these right here. Number 9. Match the following equation with the sketch that most likely resembles its graph. Y equals negative 1. Okay, now if you have an equation like this one here, y equals negative 1, versus look at this one down here, number 10. All right, number 10 says x equals negative 5. Okay. Now, since y equals negative 1, there's no x in this equation. You see there's no x at all. There's no x in this, which means it cannot cross the x-axis. So like when you graph this, here's my x-axis right there. It cannot cross it, which means it's parallel to it at y equals negative 1. So y equals negative 1 is right here. And so it'd be a line that looks like this. So on this one here, it looks like this one here, A. Okay. Now, if you have like number 10 here, x equals negative 5. If you look at this equation, there's no y. There's no y in that, which means it cannot cross the y-axis. So here's the y-axis right here. It can't cross it, which means it's parallel to it at x equals negative 5. So 1, 2, 3, 4, negative 5 is right here. That's going to be a line that looks like this. And it can't cross the y-axis because there's no y in it. All right, so if you look at this down here, I think we'd be looking at D for that. Okay, now let's look at these individually. Like we said, A was the answer for this one. What would be a possible equation for this? Well, see how it's parallel to the y-axis? This is an undefined slope, which means it's going to be x equals a value, like maybe 2. X equals 2. Because there's no y in this because it doesn't cross the y-axis. See, this one does not cross the x-axis, so it does not have x in it. So this is going to be a y equals maybe 3 or something. And this one here, again, it does not cross the y-axis, which means it has no y in it. So this is going to be x equals, and of course this could be like negative 4 or something. I don't know. Okay, so that's the difference on these. So vertical and horizontal lines, you're going to have x equals or y equals, and you will not have an x or you will not have a y depending on which one it is. Okay? All right, look at number 11 here. All right, number 11, find the slope of the line containing these pairs of points. All right, here's where we're going to bring the slope formula back in. Slope equals the y from point 2 minus the y from point 1 over the x from point 2 minus the x from point 1. This is the slope formula. We're going to use that for this problem here. All right, so now since I'll draw my 2 points here, negative 11, 4, negative 7, 5. Here's my 2 points. Okay, so you can see them a little bit better. All right, so as I use the formula then, my slope for these 2 points is going to be the y in point 2. Well, here's point 2 right here. The y is 5. Minus the y in point 1. Well, here's point 1, and my y would be 4. Okay, now on the bottom, the x in point 2. Here's point 2. My x is negative 7. Minus my x in point 1. Well, my x in point 1 is negative 11. And so there you go. That's how I set it up. And then you can just use your calculator if you need to. Do the top. 5 minus 4 would be 1. Do the bottom. Negative 7 minus negative 11 would be 4. And then simplify it. Well, it won't simplify, so that's my slope right there. So 1/4. Okay. All right. And here's another one. Use the slope formula. All right, so we're going to do it again. So I've got 9, 5, and I've got 7, 1. Okay. So we're going to do the slope formula again. All right. So there's my slope formula right there. So as I do this, the y from point 2 is over here, 1, minus the y in point 1. Well, here's point 1, and my y would be 5. All right, on the bottom, the x in point 2, here's point 2, my x is 7, minus my x in point 1, which is 9. So you just put the numbers in, and then 1 minus 5 would be negative 4. 7 minus 9 would be negative 2. And then simplify this, which the negatives will cancel, and then 4 divided by 2 is 2. So there's my slope there too. So yeah, there you go, 2. All right, so these are just using the slope formula. They're rather quick and easy. All right, let's go on down to the next one here. 13. Push this up a little bit. Okay, there we go. 13. Find the slope if it exists of these 2 points. All right, here's the slope formula again. Y from point 2 minus y from point 1, x from point 2 minus x from point 1. All right, my points are 7, 5, negative 1, 5. All right, notice these are the same here. You notice that? So when I do my slope, the y in point 2 over here is 5 minus the y in point 1. Well, that's 5. This looks like it's going to be a 0 slope. This 5 minus 5 is 0. Let's do the bottom. The x in point 2 is negative 1 minus the x in point 1. Well, that's 7. So negative 1 minus 7 is negative 8. But my top number is 0, which means this is 0 slope. All right, so there you go. The slope is 0. Okay. Now, had it been on the bottom, had the 0 been on the bottom, it would have been undefined. And so I would select this option right here. Okay. All right, look at number 14 here. Find the slope of the line satisfying the following conditions. It's horizontal, and it goes through 4, 3. Well, since it's horizontal is this way. Now, this is horizontal. A line like this is vertical. Okay, which this right here we said was 0 slope. And this right here we said was undefined. Okay. All right, well, since it's horizontal, that means it has 0 slope, so the slope is 0. Okay, so that's all we got to do there. Horizontal, it's a 0 slope. If it's vertical, it's undefined slope. Okay, let's look at this one. All right, find the slope of the line satisfying the following conditions. Vertical through 3, negative 4. Now, this don't really matter right here because it's vertical. And if it's vertical, we already talked about that, it's undefined. So this should be it. The slope is undefined. Okay. Now, let's go to 16 here. So we'll have to go to the video again on the screen here. So 16, here we go. All right, so on 16 now, it says, for the line y equals 3x plus 4, find the slope and sketch the graph. The slope, all right, this is slope-intercept form like we talked about right here. And this number right here, 3, is the slope, the number in front of the x, which is the coefficient. 3 is your slope. So right here, the slope is 3. Okay. Now sketch the graph. All right, now what we're going to do now, we're going to do this an easier way. Since this is slope-intercept form, and the slope is 3, right here, 4 is my intercept, my y-intercept. So I'm going to click the graph. I'm going to tell it I'm graphing a line. And my y-intercept is 4, which means on the y-axis, I go to 4, which is right there. Okay? And now my slope is 3. And my slope is 3, which means that's 3 over 1. So I go up 1, 2, 3, and I go over 1. And there's my slope. See, up 3 and over 1, that's 3. 3 over 1. And we're good. So that's an easier way to graph them. Okay. Let's look at another one, 17. Okay. All right. Now find the slope of this one. Okay. Now we're going to bring this paper back. Let's just do it right here on this paper here, real quick. Do the math work. This is 7y equals negative 6x. Okay, so I'm going to divide both sides by 7, which makes this cancel, and negative 6 over 7x. Okay, which right here, this is my slope. And my y-intercept, I don't have one. So my intercept is 0, 0. Okay, remember now, with your y-intercept, the x value is 0. And this is my y-intercept value, 0. So this y-intercept is 0. Let me just show you again another one here, just real quick. 3x plus 5. See, this is my slope. Here's my y-intercept, which means it's going to be 0, 5. Because when you have your y-intercept, remember, x is 0. For the y-intercept, x is 0. So in this one, my x is 0, and there is no number there, so it means y would be 0. Okay? So what I'm going to do is I'm going to plot this point right here when I graph this. I'm going to plot 0, 0, and then I'm going to do my slope, which means I'll go down 6 and I'll go over 7. So when I graph this now, I'm going to plot this point here is what it will look like. Then I'm going to go down 1, 2, 3, 4, 5, 6, and I'll go over 1, 2, 3, 4, 5, 6, 7, which would put me right there, and that would give me my line looking like that. So we're going to do that on the screen here. Okay. All right. So the slope of the line. Let's go ahead and put this in there. That was negative 6 over 7. You hit 6 and then just hit the little slash. Okay. You could do this little option right here, but I just do the little divide slash with the question mark button. Okay. Now let's graph it. So you click the graph. Go over here. You're going to tell it you're graphing a line. And like I said, the y-intercept is 0, 0. And see, it tells you your points right there. And then I'm going to go down 6, and I'm going to go over 7, which would be right there. See, that's what we're just showing you. You can rewind it and look at it on the paper if you want to, but that's what we had. Okay, so that's all you do there. 18. Here's another one. Okay, on 18, it says graph this one. Look, it goes through 0, 0, and it has a slope of 5/4. Okay, so that's pretty easy. We'll just click the graph, tell it we're going to graph a line, and it's got to go through 0, 0, so we're going to plot that first. 0, 0 is right there. And it has a slope of 5/4, which means it rises 5 and it runs 4. So we're going to go up 5, and we're going to go over 1, 2, 3, 4 right there. So that's what we should have. Okay, excellent. Okay, 19. All right, I graph this one. So we've got another one here. It goes through this point here, 3, negative 1, and it has this slope. All right, so we'll click the graph. I'm going to tell it I'm graphing a line, and I'm going to go to this point, 3, negative 1, which 3 for x and negative 1 for y is right there. Now my slope is negative 4/5, which means it's going to go down 1, 2, 3, 4, and it's going to go over 1, 2, 3, 4, 5. Always go right with your bottom number. What I usually do is if it's positive or negative, I just do the top number. If it's positive, I'll go up. If it's negative, I'll go down. But the bottom number, always go right. That way you'll never mess up. If you go to the left ever, you'll screw up. So Always go to the right with your bottom number. Okay. Getting close to being done here. Number 20. Okay. Graph the line containing the point P and having the slope M. Okay. So we've got this point, we've got that slope. So we're going to click the graph. I'm going to tell that I'm graphing a line. And I've got this point, -8, -1. So -8 for x, -1 for y is right there. Now my slope is 0, which means it goes straight across. So I can just go over however much I want to. You know, see, it's not going to change it any. If I want to go all over here, it's going to do the same line, 0 slope. Okay. All right. Now, let's go back to our paper here. We're on number 21. And on number 21, this says, in 1976, the number of high school dropouts in the country was 5,217,000. By 2005, this number had decreased to 3,118,000. Find and interpret the average rate of change per year in the number of high school dropouts. Okay. So that means in 1976, it was 5,217. This is 1976. In 2005, it was 3,118. Okay. So what's the average rate of change on this? So what you can do is we could just say these are points. We could say 1976 is 5,217. And we could say 2005 was 3,118. And we just use these points and find the slope. So if I find the slope, here's a slope formula. And so if I take the y in point 2, here's point 2, my y would be 3,118 minus the y in point 1 over here, 5,217. The x in point 2 is right there, 2005 minus the x in point 1, 1976. Okay, I'm going to bring out the calculator here, and we're just going to do the top, and then we're going to do the bottom. So on the top, 3,118 minus 5,217, that comes up -2,099. Okay, I'm going to do the bottom, 2005 minus 1976, that's 29. Okay, now I'm going to do -2,099 divided by 29, which comes up to this, -72.37931,034. This is what my calculator tells me. Okay, now it says on here, round to the nearest tenth as needed for your slope. So right here, my tenth, remember now, 10, this is 10, and it has 1 0, which means we're going to have 1 decimal place. So does this 7 right here make the 3 go up, or does it make it stay? Well, it goes up, so -72.4. This is what my slope should be, -72.4. Okay, so the average rate of change is about -72.4, -72.4 thousand each year. But does it go there, or there, or there, or there? Which one is it talking about? Okay, so let's see, let's read what's going on here. The average rate of change is about -72.4 thousand each year. The number of high school dropouts increased. Oh, this is not increased, it's going down. So that's not it. Okay, it's got to be decreased. So here's another increase, so it's not that one. It's got to be one of these two. Okay, what about C here? The average rate of change is about -72.4 thousand each year. The number of high school dropouts decreased by an average of about 72.4 thousand in the year 2005. No, that's not right, because it was from 1976 to 2005. So the real answer should be in B here. The average rate of change is about -72.4 thousand each year, the number of high school dropouts decreased by an average of about 72.4. Now this will be positive here because it's decreasing this much. So I would put positive value, and you see down here, the first one's -6. So it's got to be B because the increase is out. It's got to be decreased, and it goes from 76 to 2005. This one just says 2005. It's through these years it decreases. Okay, and one last problem here, number 22. Okay, the graph over here provides a good approximation of the number of food stamp recipients in millions from 1994 to 2004. Use the given ordered pairs to find the average rate of change in food stamp recipients per year during this period. All right, so look at these 2 points. We got 1994 and 27.9. And then in 2004, it was 22.1. Okay? And what I'm going to do is I'm just going to find the slope of this. So here's my slope formula again. y2 minus y1, x2 minus x1. So my y in point 2, here's point 2. My y is 22.1. Minus my y in point 1 over here is 27.9. My x in point 2 right there, 2004. My x in point 1 over here, 1994. Okay, now, so if I do 22.1 minus 27.9, I get -5.8. If I do 2004 minus 1994, that's going to come out to be 10. Okay. Now, this says type an integer or decimal rounded to 2 decimal places as needed. You got to read what it wants, so I need to go ahead and divide this. So divide by 10. It's still on the calculator, so it's -0.58. Which it's 2 decimal places already, so we're good to go there. So this should be -0.58. All right, that's the average rate of change. Okay. Now interpret what a negative slope means in this situation. Okay. The number of recipients increasing, it's decreasing. The total decrease of recipients over this is 0.5 million? No. It's right here, part C. The number of recipients decreases by 0.58 each year. So see, this is decreasing over here. Each year, it's decreasing this amount right here. This is 0.58. So that would be C is what you'd select there. Okay. Anyway, that's our linear functions. So hopefully you don't have any trouble with that, but if you do, contact me. Just text me anytime. You know my number. Text me, and I'll help you all I can. All right? Have a great rest of the day.